C. Predict what a graph of this will look like. Parallel lines. We already kind of proved that there will be no crisscross. What that looks like on a graph are parallel lines. So let's get our graphing calculators out and verify.
I did before you drew.
Oh, we could do it just old school on the graph. Those are pretty simple equations. You want to go old school, or you guys are going straight to your calculator?
Straight to the calculator.
Straight to the calculator. On y equals. Clear out the two old equations. We're going to put Marcus in one. 10x plus 25. Go down to y2. 10x plus 40. There's Philip. I'm going to go to window and make my window look like the graph that they had. On the x-axis, I see from 0 to 10 going up by 1. Minimum 0, maximum 10, scale 1. On the y-axis, I see from 0 to 100 going up by units of 10. So I'm going to go y min 0, y max 100, and my scale are in units of 10. That's going to make my graph easier to copy once I have it. If they gave me axes, I'm going to make my window match those axes. Now I'm going to graph. There's one, there's the other. I'm going to set this off to the side for a minute, make it a tiny bit smaller. What I already know is one of them starts at 35 and one of them starts at 40. That was the y-intercept, and this is the y-axis. So I know my lines are going to start right here and right here. Okay? Oh, do you guys want rulers? No. You'll make it work? Okay. What I also know, I'm going to do the 40 first because it's right on the grid. What I know, the slope of this line is up 10 over 1. Up 10 over 1. That's going to be this line.
Wait a second, I got a question for you.
Yes.
Why is it on 35?
One of them's on 35. One of them's on 40.
It's 25.
Oh, 25? Okay, good. Thank you. Good, awesome. I was testing you. There we go. Okay, good. So that's the one that was on 40. Its slope is 10 over 1. That's up 10 over 1 based on the units of this axis. And this one is going to be parallel.
Yeah.
Analyze the relationships of the graphs you created. Describe the relationships, parallel. Does this linear system have a solution? No. Why?
Because Philip will always have to.
They never intersect. Was your prediction in question 3 correct? Explain how you algebraically and graphically proved. Algebraically, Oh, good. The numbers didn't match. We ended up at the end with 0 equals 15, and that's not true. Algebraically. Graphically, we got lines that don't cross, parallel lines. So in 2 ways we showed you can't make these two be equal. Wait, let me double check if we're supposed to do all of this. Problem 2. All right. Oh my gosh, this one's a long one today. All right, here we go. That's all right. We're on a roll. Tanya. I know we're not doing all of this problem today because it's so long, but I bet you we can put in a little bit more. Okay, so Tanya, also in the robotics club, has heard about Marcus and Philip's savings plans. She wants to be able to buy her new materials before Philip. So she opens her own bank account. She's able to deposit $40 into her account. She has saved from her job as a waitress. She also deposits $4 each week. She deposits $4 from her tips. Write a function that represents the information that Tanya's saving. So T of W equals, what's her per week amount, Christian? What'd you say? $4 per week plus
$40.
What's her starting amount? 40. Okay, so she has a different amount per week than the guys, same starting amount as Philip. Write a linear system to represent the total amount of money. We're going to compare Tanya and Philip. Okay, so we're going to take this and put it into a y and x form. This is function notation that makes sense in our problem. But for Tanya, it'll be y equals 4x plus 40. And for Philip, what was it in y equals form for Philip?
10x plus 40.
So this is a system of equations. It's 2 equations. And usually what you're doing in a system is trying to figure out, do they crisscross? If so, where? What's the weeks? What's the money? Graph this system on the coordinate plane shown. All right, so we like our calculators. Let's get at this. Y equals, turn you back on, calculator. Y equals, I can leave in Y2 because that's Philip, but I'm going to switch out my Y1, clear, and put in Tanya's information. 4x plus 40. I see they've changed the window a little bit. I'm going to adjust my window as well. The axes show something different because if this crisscrosses, it must crisscross at a place farther out on the graph. So I go to window. The x-min and x-max and scale are the same. 0 to 10 going up by 1. The y, though, goes from 0 to what? 0 to 180, and actually the last top box will be 200. So 0 to 200. I'm changing y max. And this time, what does each box represent? How much is it going up by each box? 20. That's the scale, the y SCL. I'm going to change that to 20. Okay, here we go, graph. Okay, now, they both have a y-intercept of 40. So as you can see, both lines start right here. Bring it on down so you can see. They both start right here. One of them goes up a little bit more than the other. Okay, so this is 20. This is going to be Philip. He's going to go up by 10 every week, and I know these are 20, so I know Philip is marking it off like this. He is up 10 every week. So that top line that I can see on the graph is Philip's. I'm using the graphing calculator to help me replicate it onto the paper. And then she's only going up by 4 a week. So if this is 10, 4 is lower. Okay, if this is 10, 4, okay. I'm just gonna, that looks like about the right amount. There we go. I tried to do something that matches what I'm seeing in the graphing calculator. Do the graphs intersect?
No. Actually, yeah, at 40.
Yeah,
Actually, yes. At $40 or what does that mean in terms of time or in terms of weeks?
0 weeks.
0 weeks. Okay. All right. So, shopping spree. Anybody go Black Friday shopping? Imogen?
No,
I did.
Online, it's a lot easier.
I went to the mall.
Did you?
I got myself some Levi jeans,
Nice.
a sweater.
Did you go Thanksgiving night or did you go Friday?
I went Friday.
Okay. Good. All right. So I won't distract you. I have stories, but maybe we better focus.
Oh yeah, I want to get cousins to move their car so we could get in parking. 8 of my cousins.
Picked it up and moved
Yeah.
it.
They didn't
Interesting.
like pick it up, and they were moving it. It was really funny.
Okay. Philip and Tanya, number 11. Memo, you're such a good reader. Could you read 11 for us?
Come on, Grandma. Philip and Tanya went on a shopping spree this weekend and spent all their savings except for $3. Philip is saving $10 a week for his allowance. Tanya now deposits her tips twice a week. Only on Thursday she deposits $4, and on Saturday she deposits $6. Philip claims he is still saving more each week than Tanya. Do you think Philip's claim is true?
Okay, so let's see. They spent all their money except for $40 each. So they've been saving, but they're back to 40. Philip is saving $10 a week from his allowance. So Philip, W equals $10 a week plus the 40 that he still had in his bank account. Tanya is depositing on, she deposits $4 on Saturday, no, on Tuesday $4, on Saturday $6. How much is that a week?
$10.
4 plus 6, yes?
Isn't it supposed to be a W right after the 10?
Yes, thank you. I'm getting my notation. No, it's good to have a Jerry around here and there. Keep us on the straight and narrow.
Keep us on our toes.
Yeah. Okay. Do you think Philip's claim is true? Does Philip know what he's talking about? No, why not?
Because they're both
It was raised incorrectly.
They are now depositing the same amount. Tanya can't do it all at once. She has to do it as she works, whereas he's getting his allowance in a one-shot per week deal. But now they have exactly the same scenario going on if you look at it per week. Flip the page. How can you prove your prediction?
Using that.
Rewrite the function.
Rewrite the functions. Okay. And let's prove it. Prove your prediction algebraically and graphing. Write functions that represent any new information about the way Tanya and Philip are now saving money. y equals 10x plus 40. Y equals 10x plus 40. Oh. Write a new linear so that appears to be what we were supposed to do right here. Graph them. Huh. Let's see. Same thing. Y equals, oops, I think I'm getting low on battery. Okay, I've got Philip down here. Now I'm changing Tanya from being 4 to 10x plus 40. So I've got two identical lines put into my y equals. What's that going to look like?
One straight line?
Let's see. Here's Tanya. Here's Philip. One line. Okay, so here we go. 40. There's our line. And guess what? That is Tanya's line. And that is also, you can think of it as being right on top. There's Philip's line.
I like Philip.
Okay. Describe the relationship between the graphs. What does this mean in terms of the problem situation? Same line equals same amount of money. And one key to this, and a lot of these we're able to find a spot where they're the same amount of money, but they are the same amount of money in week 1. How about week 2? How about in week 4?
Forever.
Same amount of money forever. Every week. It's the same thing. If we were thinking of it in terms of a crisscross, they meet right here. They meet right there. They meet right there. They continuously are touching each other. So every week, it's the same exact X and Y amount. Algebraically prove this relationship. All right. You're thinking, oh, what's the point? But there you will end up with something like this sometime in the future. X plus 40 equals 10x plus 40. When we do it algebraically, we take the two functions, set them equal to each other. Now I move numbers.
Minus 40.
Minus a 40, minus a 40. 10x equals 10x, plus 40 minus 40, 0. Now what do I need to do?
Divide by 10.
No, I want to get all the x's on one side. Before I divide, minus a 10x, minus a 10x. 0 equals 0. Is that true?
Yes.
Oh, see, this one is true. Sometimes you'll do something like this and you'll get 8 equals 8 or 150 equals 150. So if you set two functions equal to each other, and that might not be so obvious that they're exactly the same, but you end up with two numbers that match, that's true forever. Or in math, we would say all real numbers are the solution. It means no matter what x we put into this equation, it's always true. Blah, blah, blah. Oh, that's it. Kind of.
Kind of, all the way.
Was Philip's claim that he's saving more money than Tanya a true statement?
No.
No. Just put a big no on 14 and we're good there.
Yeah.
Books. Return them on up over there. Homework packet. Get it on out, please.